let's talk about when we say, okay, a convolutional neural network has like certain number of parameters, what exactly that means. And this we have already seen in neural networks where we saw that like the arrows which are actually going from input to output neuron. So those weights are the parameters, and those parameters are learned. So let's try to understand what are parameters in these convolutional neural networks. Let's say we have a certain volume. You can say like it could be input image, or it could be a feature map in between your CNN. Okay, so the shape is 32 cross 32, depth is 3. And let's say we are using a filter of shape 3 cross 3 cross 3. As we discussed, if you apply this at one location, it's going to give you one number. And then you convolve over all these spatial possible locations, it's going to give you activation feature map. All right. Now, this blue block over here, these are activation values. Like it's kind of a response of your network on whatever features were coming in from the previous layer. All right. And if it's an input layer, if it's an image, then these are just pixel values. Okay, so these are data points, which means these values will change with like different samples. And these are not parameters. Okay, so these values are not defined by the network. It is property of the data. Again, these activation maps, these are not parameters. This is kind of a data flowing in your network. So these values will depend upon what kind of features were present in the previous layer. All right, so these are not learned. These are just like showing how your data is flowing. So then what exactly are parameters which we are trying to learn? So these filters over here. Okay, so let's say if we just consider one filter, which is 3 cross 3 cross 3, which means this filter will have 27 different values. All right, so those 27 different values are actually used when you transform this input volume to the output volume. All right, so those values are actually parameters. They are independent of what input sample you will use. Okay, let's say you select like image number 1. This filter is not going to change. It will remain the same. The only values which will change is this blue block over here and this orange block over here. And if you pick another image, again, the values of blue block will change. The values of orange block will change. The values of this filter will not change. Okay, so then this filter is actually the parameter of your network. And this filter is defining how this activation map is actually transformed from like this stage to a different stage. Okay, so which means if we just consider one filter, we have 27 different parameters. And we were talking about like sharing of these parameters, and we are sharing because we are applying the same filter at all the possible locations. Okay, so that's what like parameter means in a convolutional neural network. So let's say you have this input image and you have a convolution layer, which is like some set of filters. And let's say we are using 6 different kernels or 6 different filters. So I will use like these terms interchangeably, kernels and filters. We have seen it means the same thing. So we are using 6 different kernels, and the shape of the kernel is 3 cross 3 cross 3. So that constitutes like this convolution layer. And if we use this convolution layer on this input data, we'll get something like this form of activation map. Now, if we have to say, okay, how many parameters we have in this particular convolution layer, we can just count these parameters. Okay, so this is going to give you 162, which means this convolution layer has 162 different parameters. Similarly, you can actually create, you can have more than 6 kernels. You can have as many as you want. And that will change the number of parameters you have. So one thing which will change the number of parameters is how many kernels you're using. The second thing which is going to change the number of parameter is what is the shape of your kernel. Okay. And then you can stack like these convolution layers on top of each other. And if you compute number of parameters for one layer, you can just add like for all the layers. And then you can say that, okay, this whole network actually has these many number of parameters.